Hello everyone, welcome back to a new section. We have section 2 from chapter 5, flat mirrors. Before we talk about flat mirrors, we should first know what is a reflection. The reflection of light means that light changes its direction when it is hitting a surface. Same as, for example, when you have a ball and you throw the ball at a wall and you'll see that the ball is going to change its direction. Light, when it hits a surface, it's going to change its direction. Or we can say the bouncing of light off surfaces. We have two types of reflection. We have diffuse reflection, when the angles of incidence and angles of reflection are not the same. And it happens on rough surfaces like a stone, a carpet, a paper, an unpolished wood. These are all types of diffuse reflection. We have specular reflection. It happens on shiny surfaces and smooth surfaces, like the surface of water, a plane mirror, or a flat mirror, or water in a calm day. These are all types of specular reflection. Specular reflection happens when the angle of incidence is equal to the angle of reflection, and we will know what is angle of incidence and angle of reflection in a minute. We have law of reflection. By the way, in this chapter, we're going to deal mostly with specular reflection. We're not going to talk about diffuse reflection. We have law of reflection. If you have a surface, a smooth surface, let's say this is a surface of a mirror, we have something called, just to simplify our understanding, we're going to say that we have something called normal line. Okay, this is an imaginary line. It does not exist. It makes an angle of 90 degrees with the surface of the mirror, or with the surface of the object we have. Here we have a plane mirror or a flat mirror. Then let's say we have a source of light here. Okay, this is a source of light. An ray is coming from the source of light. This is going to be called incident ray. This is called incident ray. The angle that is between the normal line, or the line perpendicular to the surface of the mirror, is called theta. This is called what? This is called angle. This theta is called angle of incidence, or angle of the incoming ray. Because this is a specular reflection, a mirror is a specular reflection, the angle of the reflected ray here, let's put a number. Let's say this is going to be 30 and this one is going to be 32. Because this is specular reflection, it's a smooth and shiny surface. Then this is going to be what? This is called the reflected ray. This is a reflected ray, and the angle between the normal line and the reflected ray is called theta bar, and it's called angle of reflection. Now we have learned that specular reflection happens when the angle of incidence and the angle of reflection are the same. In this chapter, we will be dealing with specular reflection only. This is the law. This is basically the law of reflection. Angle of incoming ray, or angle of incidence, is equal to angle of reflecting rays, or angle of reflection. Then we have the properties of the image formed by a flat mirror. The flat mirror is basically the mirror that you're using on a daily basis to see yourself. It has some properties. The first one is that the image that you see is virtual. It's not real. What does virtual mean? Virtual means that an image is formed where light rays seem to appear to come from that image, but they actually don't. Okay, this is what's called virtual image. There is another way we can find out whether an image is virtual or real by projecting that image on a physical surface. It's going to be if it's real, it's going to be projected. If it's not real, it's virtual, it's not going to be projected. So the first property is that the image is virtual. The second property is that the image is upright. You don't see yourself upside down. You see that your image is upright. Then we have the size of the object here. As you see here, the size of the object is still the same. It does not change. Then the distance between the object and the mirror, and the distance between the image and the mirror is the same. Let's say this is 2 meters, and this is also going to be 2 meters. It's not going to change. These are the four properties of the image formed by a flat mirror. We have a question here. Why can't images formed by a flat mirror be displayed on a physical screen? Because they are virtual. They cannot be projected or displayed on a physical screen or a physical surface. This is a good example of the application of flat mirrors. You'll see that the ambulance, the car, its name is written in inverse, starting from E, like this. Okay, it's not written like this. That when you see the car, the ambulance, inside the mirror of your car, it's going to be reversed back, and you will see the name, or you will read the name correctly. Because flat mirrors, yes, we said that the image is going to be upright, but it's going to be reversed, meaning if you raise your right hand, it's going to be left on the image. If you raise your left hand, it's going to be right. So all your image is going to be reversed. How can we draw if we have a pencil? Excuse my terrible handwriting, my drawing. Let's say you have a pencil like this, and you have a screen or a mirror, a flat mirror. We want to draw just the tip of the pen. We don't want the whole pen. We want to know how the image is formed here, this tip. So let's read and follow the instruction. It says first, draw the mirror and the pencil tip. We draw the mirror and the pencil tip. The first ray should be perpendicular to the tip of from the tip to the mirror. So we have the tip here. Let's draw a perpendicular line. How is it going to be perpendicular? This is going to be perpendicular. Then it's going to be what? It's going to be reflected back. Then draw the second ray at an angle to the mirror, reflecting at the same angle. Since this is going to be a specular reflection, so my image is going to be what? My ray is going to be having the same angle. So this is the angle here. So let's say here. And that's it. And the fourth instruction says trace the rays. So we're going to trace the rays and make a dotted line. So this is the ray here. Then here trace this to the tip. So this is basically the image formation of the tip of a pencil. We have what? We have placing two mirrors like this, perpendicular, okay, meaning that it makes a 90-degree angle with the other mirror, is going to create three images. Two images are formed by the reflection of light from the object, and the third image, as you see here, is going to be formed by the reflection of the two mirrors. If you place two mirrors parallel to each other, maybe you have tried this, you're going to see that infinite number of images are going to be formed. Parallel, it means the angle is going to be 0 between them. We have the motion of the object relative to the image. Let's take this as an example, this one. So if you can try this with a mirror, with a plane mirror. If this object moves 1 meter, okay, close to the flat mirror, this image is also going to move 1 meter. So relative to this observer, this image is going to have twice its speed. So if this meter is going 1 meter per second, here this image is going to be moving 2 meters per second. Careful, we're not considering the image, the mirror here. We are comparing the motion of the object, the observer, and the image. You can try this. Stand in front of a mirror and walk 1 meter closer to the mirror, and you'll see that the image is going to also get closer by 1 meter. So how many meters has the image changed? The distance of the image, of course, is going to be 2 meters. So the speed of the image relative to the observer is going to be twice the observer's speed. If you walk 1 meter per second close to the mirror, the image is going to be walking 2 meters per second. This is it for this video. In the next video, we will be solving section review. See you in the next video.